In this video, we are going to discuss about process state diagrams and what are the different cues that are associated with process state. What is a process state? A process in its lifetime while executing, it changes from one state to other state. There are five states a process can change from one state to other state. First one, new. Second one, ready. Third one, running. Fourth one, waiting. Fifth one, terminated. Okay, so what are those five states? First one, ready. Sorry, new. Second one, ready. New. Second one, ready. Third one, running. Fourth one, waiting. And fifth one is terminated. This new in some textbooks, it is also given as begin or start. This terminated is also called as exit or stop. Okay, so let's see what is new state. The definition of new state says that it is a process is about to be created or process being created. Process about to be created or a process being created. What is mean by that? A file that is stored in the hard disk is a passive entity. Then the file that is stored in the hard disk, we'll call it as, that is a passive entity. Whenever this particular new state, a process that is an icon of a particular program. If you see an icon on your desktop, see there are several icons here. If you double click on this particular icon or if you select it and press enter, then the process is moved from hard disk to main memory and it will become active. That means until the process is stored in the hard disk and you did not double click on it, you did not open that particular uh, application, then it is passive state. Okay, once you double click on it, then it comes to new state, that is a process is created. Okay, once the process is created, it is in the new state. Okay, and the process after creating, it has to be admitted into ready queue. It has to be admitted into ready queue. That means the process in the hard disk which will be loaded into main memory. So ready state, it belongs to it is associated with device called main memory, that is your RAM, random access memory. Okay, so the process which is created and loaded into main memory, the state will be changed to ready state. Okay, the state will be changed to ready state. So the process is moved from hard disk to main memory, then the process in which state? It is in ready state. So ready state consisting of all the processes which are waiting to assign onto assign to a CPU, waiting to assign to, that is process P1, process P2, process P3, all these are put it on to ready queue because they are ready to be executed by processor. They're ready to be executed by processor. So the processes which are ready and to waiting for executed by CPU are put it on to ready queue. Once the process is ready and put it on to ready queue, there is a program called CPU scheduler. The CPU scheduler will select one of the process out of all these process, will select one of the process, and that particular selected process will be sent to CPU at some particular point of time. So that is called schedule dispatch. That is, the process is moving from main memory to CPU. Okay, so that means that if P1 is selected, P1 will be moved from main memory to CPU. So the instructions of P1 is starting to execute, that is instruction 1, instruction 2, instruction 3, one after other it will be executed by CPU. So a process which is in CPU will call that particular state as running state. Okay, the process which has already started execution by CPU, the process is in running state. Okay, so either it the execution will be completed, or if there is any interrupt, that is clock interrupt, or it needs anything, then the process will be moved back to ready state. That means, see, after, if P1 enters into CPU after executing for 2 milliseconds or 10 milliseconds or 10 milliseconds, there is a clock interrupt, and P1 has to go back to ready queue, and next process P2 will be entered into CPU and it will execute for 10 milliseconds. Then P2 will also send back to ready queue, and next, that is main memory, and next P3 will be loaded into CPU. Okay, so this is there, that means there is a interrupt that will be occurred. This interrupt makes the process change from again ready running to ready. But while executing the process instructions, while executing the instructions, if a process needs any IO event, that is, if a process needs any IO event, what is mean by that? Either it has to go to printer and print 10 papers, or it requires any network, okay, related information, or it needs any internet connection, or the process has to scan some particular document. So all these are IO operations. If there is any IO event required by process, the process will be moved from running to waiting state. Running to waiting state. So if a process that is taking prints of 10 papers or 20 papers, we can say that it is in waiting state. And some textbooks, this waiting state is also called as suspended state. We'll call it as suspended states. Once the IO events are completed, all the IO event is completed, IO instructions are completed, then it is not moved back to CPU. Okay, it is moved back to your ready, that is main memory. The process will be sent back to main memory from your printer. Let us take from printer to main memory. Here we need to note one particular thing. CPU does not interact with any other device except main memory. Okay, so CPU only interacts with main memory. CPU does not directly interact with hard disk, or CPU does not directly interact with any other device, printer, scanner, etc., any other IO device except main memory, that is your RAM, random access memory. The data transfer has to be in between your main memory to CPU and CPU to main memory. Okay, so if a process that has completed all the instructions I1, I2, I3, so on up to all the instructions IN, then once all the instructions are executed, then the process will be terminated. So it will have a state called terminated state. Okay, so if sometimes there is some particular processes which will not be execute all the processes, all the instructions of that particular process, we forcefully terminate the process. Forcefully terminate the process. So the execution has to be aborted in between, and we cancel that particular execution. So still that has to be terminated. We terminate the process forcefully. Okay, so when a process is moved from running state to terminate state, either all the instructions are executed by in that particular process, or if we forcefully terminate the process, then we'll the state will be changing from running to terminate. Okay, so new to ready will be done when a process is moved from hard disk to main memory. Ready to run is done when the CPU scheduler selects a process which will be going to CPU, and the dispatcher process will actually dispatch the process from main memory to CPU. A process which will be in running state and went for waiting state when it needs any IO event. It went for any IO event or IO event. So next, a process After completing all the IO events, the process will be changing from waiting to ready state. That is the device IO device to main memory. IO device to main memory. Then, if all the instructions are completed, then the process will be moved from changing the state from running to terminate. Either all the instructions are completed or program has to be terminated abruptly. Then we are changing the state from run to terminate. And there is one more event we forget, that is run to ready. Here I can write run to ready. If there is an interrupt that will come, either a clock interrupt, the best example is clock interrupt, so that the process has to move from running state CPU to main memory. When a interrupt occurs, there are several other interrupts occur where the process will be moved from CPU to main memory. Okay, so what is mean by context switch? Context switch means a process that is moved from main memory to CPU and CPU to main memory. That is, let us take the same example. A process which is in main memory, that is P1, P2, P3, so on up to P10. Okay, so CPU scheduler will program will select one of these process in the ready queue. Okay, so after selecting it, this particular P1 has to move from main memory to CPU, main memory to CPU, and some instructions I1, I2, I3 will be executed. Okay, then if the time given to this one is completed, then the process P1 has to move from CPU to main memory. Then P2 will be loaded into CPU. Okay, the process of the process of scheduling the one process from other process, moving one process from other process, that is P1 has to move back to main memory and P2 has to send it to CPU. Okay, this process is called context switching. Okay, this process is called context switching. See, while context switching, whatever the modifications are done, all the modifications has to be done in process control block. That is how many instructions are executed. That means what is the next instruction. Okay, what is the next instruction address that has to be changed, and P1 next instruction address, that is I1, I2, I3, next I4 instruction has to be executed. This change has to be there. Then what is the memory next memory location, that is memory location 1, 2, 3 is done. Next memory has to be changed is 4. And what are the different local variables that has been changed, global variables that have been changed, all the changes has to be loaded into main memory. First change first, then changed into main memory. Okay, so the process of moving the process it is a concept of moving a process from main memory to CPU and CPU to main memory is called context switch. Usually occurs at ready to in this particular concept, this is a context switch, or we will also call process switching. Okay, that's it. We'll see later next class.